All right, welcome back to Mr. P Helps with Algebra. This is Unit 5, Topic 1, Lesson number 4. So we're going to be doing floor and ceiling step functions with this, or least integer and greatest integer functions, if that's the way you know it. Start off with a function notation question. F of negative 1 is what? So I look at the piecewise and I ask myself, well, hey, which domain set does negative 1 fall into? And it falls into this one, not this one. Negative 1 is between negative 2 and 1. So the answer here is negative 4, because it tells me right there. F of 2 tells me, well, first of all, 2 is in between this domain, which means I have to use this function, or this part of the function, I should say. 2 times 2 is 4. 4 minus 5 is negative 1. So notice what I did there. First, I figured out which piece I have to use by using the domain, and then I plugged that in for x and solved. Over here, same thing. So first thing I do is figure out, well, hey, which piece does it use? You might be saying it could be both of them. Nope, not true. Has to be the second piece, because remember, negative 1, this is not or equal to, so the answer is 0. F of 2, 2 is between 1 and 3, so the answer must be 1. Pretty easy warm-up. Now, this is one of the rare times where I'm going to have to skip the homework, come back to it at the very end, because I don't want to do this right now, because you probably have no idea what any of this stuff means. These are floor functions and step functions. Now, we're going to talk about okay, so what do you probably notice? Well, you notice that this is increasing, this is also increasing, and then this one's going diagonal. What you might have also noticed is that graph A, the open dot is on the right-hand side, where in graph B, the open dot is on the left-hand side. That is also important. Now, this is what we call a floor function, and this one happens to be a ceiling function, which I'll explain to you in just a moment. In fact, let me just go to here and answer some questions. So f of 0.3 in graph A, f of 0.3 is 0, because it falls right here on this piece. So that one would be A. F of 0.3 here would be 1. And f of 0.3 here would be 0.3. Yeah, echo. F of 2.7, I shouldn't have set it off. 2.7 be about right here, so the answer there is 2. In graph B, f of 2.7, 1, 2, 2.7 would be 3. And in this one, f of 1, 2.7 would be up 0.7. Now, you might be noticing what's happening here. This is a floor function, this one's a ceiling function, and this is a fractional part function, which fractional part is probably the one I'm going to talk the least amount about. F of negative 1.4 is negative 2. F of negative 1.4 is negative 1. And f of negative 1.4 is negative 0.4. All right, so how would you describe the functions as a value? So this f of x and the x value. So what you should have noticed is that all of these numbers are the nearest integer below the number, whereas all of these numbers happen to be the nearest integer above the number. Okay? And these numbers, you'll notice that basically they're called fractional part because the answer was the fractional part. So in 2.7, the answer was the 0.7. It's just the decimal part, which we call the fractional part. All right, so basically these notes right here, I'm going to pull up something. Here we go. So this is the same thing with all the notes already done, which saves me a lot of time in the video because you know I'm limited to 15 minutes. This is a floor function. The reason I like to think of the floor function, well, first of all, look at the symbol. Notice that the x has a floor to its house, whereas the above it is empty. In a ceiling function, it has a ceiling, but it has no floor. And in the fractional part, you've just got your brackets around it. So it's just I don't know any good way of remembering that one. We do also call this greatest integer function because it does have a greatest integer. So the answer is the number that is below it. This is a least integer because just basically the opposite. There is a least integer, which means the answer is going to be the number above it. The domain of this is all real numbers because remember this is a continuous piecewise function, same with all of these. The range is all real numbers, but this range, no, it doesn't go up and down infinitely. The entire answer is between negative 1 and positive 1, which is what you see right there. Okay, so I think I've pretty much gone through most of the notes, so now we can go back and do some real work. So, use the definition of the function to evaluate the following expression. So this is a floor function. I know that because it's got the symbol underneath, so it looks like it has a floor to the number. And I can go back here. F of 3.9, 1, 2, 3.9 is 3. So remember what we talked about earlier. So a floor function means the answer is the nearest integer below that number. Whereas a ceiling function, yeah, you're going to notice that this is pretty easy here. The nearest integer above it, now above it is 2 and below it is 1. And the answer is 2 because it's a ceiling function. It's the nearest integer above it. Fractional part function, the answer here is going to be 0.1. Fractional part, nope, sorry, ceiling function, which means the answer is the nearest integer above it. Now, some of you might get confused here, but -2, remember, is above -2.5. So remember, rules with negatives, the bigger the number, actually the smaller it is. -4.2, this is a floor function, so we want the nearest integer below it, which would be -5. That is below this. Fractional parts, so this is going to be -0.7. Now, something I didn't talk about before in fractional parts, you always take the symbol. So if it's a negative, then this has to be negative also. It's the fractional part, and just get rid of the whole number, basically. That's all you're doing. Floor function, the greatest number below it would be 8. The greatest number above, I'm sorry, the least number. Okay, so maybe I wasn't clear earlier. The reason this is called a least integer, because what we're doing is we're looking for the least number above it. Okay, so that would be 7. Okay, and this is called a greatest integer function because we're looking for the greatest integer below it. The greatest integer below 8.3 is 8. Okay, so that's an integer. All right, describe the transformation. Now, there's 2 ways to do this. So you remember the parent function that I showed you earlier. These are called parent functions because this is what the function looks like. This is just the floor function of x. Parent function, basic as it gets. This is the ceiling function of x, and this is the fractional part of x. Now, the reason I know that is because I'm looking at where the dot is. Notice on each piece, there is a bottom domain answer, not a top answer, because that's an open circle. Here, there is a highest answer. There's just not a lowest. Therefore, it's called a ceiling function. All right, so getting back to this, how would you describe that function? How would you say this is a floor function, first of all, because the black dot is on the left. Each piece has a lowest point, has a floor to it. Now, 2 ways you can visualize this, because remember the parent function had a piece right here, and then it went up like this. So it looked the same as this, but it was more like right here. It went right here in this direction, this whole thing. So you can either see this as a transformation that has shifted everything to the right, or if you can imagine it, it's the same thing as shifting everything down. Now, first of all, this is a floor function. And just like quadratics, if you remember the vertex form, like the x minus h squared plus k, everything inside the parentheses was the opposite. So inside the parentheses moved it left to right, and minus made it move right, and plus made it move left. Same thing goes for floor and ceiling functions. So whatever's inside, so I could make this the floor function of x minus 2. And what that means is the parent function got shifted. Every single piece got shifted 2 spots to the right. So if you can imagine taking this graph and shifting all of these pieces 2 spots to the right on the coordinate graph, what you end up is with this. Okay, but you could also shift everything down. So there is a second answer here. Or you could say it's a floor function of x with a minus 2 on the outside. Because remember, just like k, it's just what it is. If it's minus, it's moving down. If it's plus, it's moving everything up. All right, so now if you understand that, this might not be so hard. This is a ceiling function. It's a ceiling of function of x that has either been, remember, this was the parent function. It was right here. So this piece either got moved up 2, so it would be plus 2, or you could say this is a ceiling function of x plus 2, which means every piece, including the piece in the middle, got moved 2 to the left. So this explains shifting to the left, and this is showing moving every piece up 2. So there's 2 ways of writing the exact same function. Just like in, quadratics, there's lots of ways you can write. You can write in vertex form, you can write in standard form, you can write it in factored form. So it's 3 ways of writing the exact same function. Describe the transformation here. Now this one's a little tricky because this one has a dilation factor. So this is first of all a floor function. You probably noticed that right away because of the dot here. It's a floor function of x. And I know it's just x because there's no shifting here. The piece is still here at the origin. But this one's a little different because instead of the next piece being right here, it's been shifted up. Instead of being up 1, right 1, the next piece is up 2, right 1. So what this means is it has a dilation factor of 2. And it's positive 2 because these pieces are going up. Had the pieces been going down, it would have been a dilation factor of -2. All right, so now I think we understand enough in order to get to the homework. which is one more page back. No, it's not. There it is. Oh, I just missed it. Ceiling function of x with a -3 on the outside. So ceiling function means that the colored dot would have been here and the open circle would have been here, but everything's been shifted down 3. So 1, 2, 3. So there's my dot, there's my open circle, and then each other point is going to be just like that, because it has a dilation factor of 1. We assume if there's no number there that it's basically 1. Now I know this is a little bit time confusing actually drawing it, which I might have to skip because I'm already at 10.5 minutes. So if I do just describe what the function looks like, you'll just have to listen to me. This one has a dilation factor of -2. Remember I talked about that earlier. It's a floor function, which means always put the closed dot on the origin. It always is the parent function. And it's a floor function, which means it has a lowest point, which means it doesn't have a highest point. So it looks like that. So once you've got the point on the origin, now the rest is pretty easy. Now, this one, the next piece is going to be 2 below it. So it's going to be going down. So it's going to be like right there, down 2, right 1. The next piece is going to be there, and then up 2, left 1, there, up 2, left 1, there. And there we go. There is that function. All right, I'm going to erase that one again. This one is x plus 1 inside the floor function. So a floor function of x plus 1. I don't like to say the other letters. I'm just going to always say x. So that means it's going to have a shifting of, remember, it's the opposite of what you would think. So it's not going to move right 1. It's going to move left 1. So instead of the closed circle being there, it's going to be here. It's moving left 1. And it's a floor function, which means it has a lowest point. So this is going to be an open circle here. All right, and then here and here and here, it has a dilation factor of 1 since there is nothing there. And this is one of those cases where I'm going to say, you know, just finish the rest. So I did this side, but you've got to also do it over here as well. So if I notice that you turn this in without the answer over here, I'll know that you just paused the video and copied. All right. Next one. This one's got 2 transformations. So usually the closed dot is right here, but it's moving once right. Closed dot moves once right, and it moves up 2. So now the closed dot is here. So now I ask myself, is this floor or ceiling? It's a ceiling because it looks like this. So that means it has a highest point, so it looks like that. Perfect. And the dilation factor is 1. So that means it's just going to go up 1, right 1, up 1, right 1, up 1, right 1. Close dot, open, 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 connect, connect, connect. And once again, it's going to go infinitely in this direction also, and you got to finish that as well. All right, so once again, I'm testing to see, are you watching the video? So make sure that you finish this diagram that I did not finish. It's with all pieces that look like this. I know mine's a little bit sloppy. Looks like a dumbbell with the right side closed. All right, thanks again for watching. Please give it a like to help you learn something about floor versus ceiling functions, and subscribe if you haven't done so already. Yes, definitely give me these likes because I think this video is great. Have a wonderful day. See ya.